the classic crypto system were given in this module 1. Okay, and also we saw during World War 1 and 2 how this crypto system were in use and what role they played during World War 1 and 2, right? And also we saw the taxonomy of cryptography, wherein I have just listed the symmetric cryptography as well as public cryptography, right? In the last, I just spoke about hash functions, right? So this hash function, this module 2 is completely, we are going to discuss about hash functions, okay? And also we studied the different attacks that can be performed on the algorithms used for encryption and decryption. So all these topics we studied under module 1, but this module 2 is completely on hash functions. Okay, here we are not going to discuss all the hash functions that were in use and that are in use nowadays. Okay, but only we are going to see why it is used. I mean, what exactly the hash function is. Okay, what are its characteristics. Okay, and also what is the motivation for this hash function design, as well as we are going to discuss in detail about one hash function, that is tiger hash. Okay, so after that we'll see the uses of hash function and some non-cryptographic hash functions which they use it in many applications. Okay, so this is the outline of this module. Okay, so we'll see from the definition of hash function. What is hash function? Anyone? Hash function? Okay, hash function, it is any function that takes an input of any size. So do you remember a function which takes an input of any size and produce an output of a fixed size. So let me consider this picture. Okay, you can see in this picture, this is a hash function where you're going to perform some calculation. To this function, I'm feeding a message or a data or a text which is of arbitrary length. The size can be any length. Message can be of any length. Okay, when you feed this message to this hash function, it generates the output that we call it as a hash value, and usually we represent it with the letter H, and this output will be of fixed size or fixed length. So whatever message you feed for this hash function, the output will be of fixed size and it will be the smaller length compared to the input. Fine. So why basically this hash function is used? It is used to verify the authenticity of a piece of data, or you can say to check the authenticity of any message, the message which is involved in the communication between the communicating parties. Okay, so let's see few examples where, I mean, a few hash functions which were in the use during initial days, or now whatever the hash functions that we are using. Okay, I have just listed few of it: SHA-01, SHA-1, SHA-2, SHA-3, and message digest 5. See, there are few more with respect to SHA. Okay, SHA is what? Secure hash algorithm. Okay, so these are the series of SHA. We also have SHA 512 algorithm as well. So compared to all other algorithms, actually message digest 5 is in use. I mean, this message digest 5 is widely used in in the market, or you can say in as a hash function to verify the authenticity of a message. Okay, I hope this definition is clear. This is not given in your textbook. Just to give an introduction about this, I have taken this content. Okay, so next, let's see what are the other application of hash function. I mean, in general, where it is used. First one is password storage. Okay, so hash function, this is very important usage of hash function. Okay, see, let me consider an example where you create a Gmail account or a Google account. Obviously, you have to provide the username and the password to to log into your account, isn't it? So that is the first thing. So when you create a password, will it be stored directly as it is in the password database? No, right? That is not the proper way, right? So what if you do so? The attacker can attack this password database wherein he'll come to know the password of all the users of Gmail account, right? So easily he can get the access to their account. So avoid such action. What Google or any what to say company, they'll use this hash function to store this password. What will they do? They use a particular hash function on the password that is given by the user. Generates, when you apply a hash function on a message, obviously it generates a hash value, right? So that hash value is stored in the password database. Okay, so even though attacker attacks such database, obviously he'll end up with some junk value according to him, right? Using that junk value, it's not possible for him to recover the password. So if any flaws exist in the hash function, then only attacker can crack the database and he may recover the password. Or else, if you use a strong hash function, obviously it looks like a junk value which are stored in the database, password where it isn't stored. Okay, that is one application. Next application, I can say it's data integrity check. See, hash function provides the user about the correctness of the data. Like, so see, consider if two parties are involved or two users are involved in the communication, then whatever the message that's sent from the sender side is received as it is at the receiver side. The assurance is done by with the help of hash function. I hope this is clear to everyone. And the last one I listed here as security. See, this hash function also provides security for the messages, I can say. So since it provides a security, how it provides the security, you might have started digital signatures, right? So what is digital signature? Yes. So actually, digital signature is a method which is used for verifying the authenticity of messages. The messages which are involved in the communication. Okay, so computation of digital signature is done with the help of hash function. Fine. So we'll see in detail with respect to this digital signature in module 4. Okay, we are going to discuss in detail how it is generated and what is the importance of this digital signature in the network. Okay, so this is all about the application. Okay, next we will see any function, you can't say it is a hash function. Okay, see, if I say f of x is a function, you can't say it is a hash function. Why? Because that particular function should have the required characteristics. Okay, so those characteristics are compression, efficiency, one way, weak collision resistance, and strong collision resistant. I'll repeat. The first one is compression, second one is efficiency, third one is one way, and the fourth one is weak collision resistance, and the last one is strong collision resistance. Okay, so if any function possesses these characteristics, then that function we can call it as a hash function. We'll see each characteristics now. Okay, so the first one is, and do remember, hash function is represented with the help of h of x. Okay, x is a message that you want that is treated as an input on which hash function is performed. Fine. Okay, we'll see the first characteristic, that is compression. Actually, this is for any size input x. Let me treat it input as x and let it be any size. Okay, for this, when you perform this hash function, the output of the length y should be small compared to the message length, which you treated as input. the length should be the small. For the same one, whatever the output that you get, the length should be small. Okay, that is first characteristics. That is compression. Let's move to the next one, efficiency. So, efficiency is that it must be easy to compute h of x for any input x. Okay, so whatever hash function you're following, then that should be easier to compute. It should not be a tedious one. Okay, that is the second one. And third one is one way. Okay, so here let me consider a value, say y. Okay, let me consider the value y. It's computationally infeasible to find a value x such that h of x is equal to y. So if you have a value y, then that means the output of the hash function, if you have this, it should you should use the hash function in such a way that it is infeasible to find an x. If you have the value of y, using this you are not able to find the value for x. That is one thing. Okay, that is one more characteristics of this hash function. And the next one is weak collision resistance. So what is this weak collision resistance? Let me consider this. The value x is given and also h of x is given. Okay. So with this, it is infeasible to find any value y with y is not equal to x such that h of y is equal to h of x. What it says? Yes. See, if you follow this, you can say that uh, this requirement is that it is not feasible to modify a message without changing its hash value. Okay, I'll repeat. If you have the value of x and h of x, you are not able to that means you should use hash function in such a way that it's infeasible to find the value of y even though you have the value of x and h of x. Okay, such that y is not equal to x, therefore h of y is equal to h of x. So what can you conclude with this statement? That is, it is not feasible to modify a message without changing its hash value. That means you for each and every message you will be having a unique hash value. Okay, that is weak collision resistance. The next one is strong collision resistance. See, this characteristic says it's infeasible to find any x and y. Okay, it is infeasible to find any x and y value with x is not equal to y such that h of x is equal to h of y. So what you can conclude with this? See, we cannot find any two input that hash to the same output. That means what? Again, it indirectly says that no two input can have the same output. Okay, I hope is this clear to everyone? The characteristics of hash function.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay, we'll move to the next. And do remember, this is one of very frequently asked question, the characteristics of hash function, right? So the last point here is that even though following all these characteristics, there is a chance of collision. Okay, so but it may be hard to find this collision if it exists in any hash function. Fine, we'll see what does this collision means and all in the later slides. Okay, so next we'll see the motivation for this hash function. I mean, what made the designer to design this hash function, right? So let me consider this scenario where Alice signs a message. Okay, uh, Alice, or this is one sender, or you can say the party involved in the communication. Alice signs a message M using her private key. Okay, so she'll encrypt the message using her private key, then she'll compute s is equal to m of Alice. So after performing encryption, she'll send m and s is equal to m of Alice to the other party involved in the communication, that is Bob. Okay, what Bob will do, the Bob will verify the received message. Okay, he'll verify, I mean he will receive and he'll think that the received message is sent by the Alice, but there is no proper method to verify it. Okay, so there is one problem with this, that if m, the message that Alice wants to send it to Bob, is big enough, I mean it's a large message wherein the content is huge, then calculating m of Alice, that means provide, I mean generating the cipher text would be costlier for the Alice. Okay, so it takes too much of time, and also it consumes lots of data to send it over the network. So this is one problem. So to overcome this problem, what designers have done, they have developed a new method. You can call it as a hash function, where Alice signs this message using hash function. Okay, and output of this hash function is smaller, you know that, right? So output of any hash function will be smaller compared to the length of the original message which you treated as input for the hash function. Okay, next what she'll do, she'll say, after signing it, I mean after performing hash function on this message, she'll send that to Bob, that is s is equal to h of m of Alice. Fine, then Bob verifies it by performing hash on this, and he will retrieve the message that is sent by the Alice. Okay, so that is depicted in this diagram. You can see Alice computes uh, what s, that is message, performing hash function on the message, and it is sent to the Bob. He verifies at his end, and he'll retrieve the message that is sent by the Alice. Okay, and the next is, that is whatever I explained in the previous diagram, that is listed out here. Okay, so as I said, he verifies the message. Now, what properties that hash function should satisfy? What does it mean? There should not be any collision if anyone using any hash function. So let's consider how the collision may happen. Okay. So consider another scenario where Trudy is nothing but treat him as a attacker. Okay. What the attacker does here, he finds a message. Okay, any message, so that hash of the message, this m is which one? The message that was supposed to send by the Alice to the Bob. Okay, when hash function is performed on this message and another message, then the hash value is equal. Say h of m is 2, then h of m dash is also 2. What does it mean? Hash value with respect to this m and this m is same. If this is the case, then you can say there is a collision in the hash function. Okay, so what Trudy will do, he will replace M and S. See, this was supposed to send by Alice to Bob. Okay, what he'll do, he'll replace this message with M dash S. But will the Bob can detect the tampering? No, right? Because hash value of both the messages are same. Okay, so this is a scenario where you can find the importance of hash function as well as the drawback of hash function. Right? So this is when he performs the hash function on this m dash, he'll end it with the Alice message, but he'll not be knowing what exactly the message sent by the Alice, because this message was tampered while sending from Alice to Bob. Okay, so that is one thing. Let's see a use case with respect to this hash function. Am I clear to everyone till now? Yes.
Yes,
Yes,
ma'am.
ma'am. Yes,
Okay.
ma'am.
Okay, let's consider this use case. See, this use case what to verify whatever we discussed in this slide. Okay, let's consider an example where you want to download a latest version of this Firefox. Okay, Firefox browser. So it so happened that you were not able to download it from the Firefox or Mozilla website. Okay, so consider this is the problem or the scenario that you faced it now. Okay, so you were not able to download it from the Mozilla website. That's why what you will do, obviously you will try to find the latest version of Firefox browser in some other website, isn't it? So, where you searched for this latest version of Firefox browser in some other website, uh, consider you got the proper link and you downloaded the latest version. Okay. Now the question is, you want to make sure that the one which provided in the Mozilla website is same as the one which you downloaded from the other website. Okay, so you just want to make sure the one which you are having it is a authenticated one. So what you can do, you can perform or you can use a checksum calculator. Okay, where you can compare a checksum using a particular cryptographic hash function. Okay, so I hope you are able to follow this point. So to just to compare the files which you have with you, you are going to compare that file with the one which is there in the Mozilla website. Okay, so how do you compare it? By using a cryptographic hash function. It may be anyone. Okay, it's not that SHA2 should be used. Any or hash function can be used to perform the comparison between the files. Okay, when you compare it, okay, you will you will end up with a checksum. Okay, so that then compare that to the one the published on the Mozilla site. See, after some time, think that you were able to get the file under the what Mozilla browser. Okay, the authenticated file and the one which you downloaded from the other file. You perform hash function on these two files and check the output. If it is same, okay, if it is same or if the checksum are equal, then you can make sure that the downloaded you have is the one Mozilla intended you to have. Okay, this is one scenario where the hash function plays a very important role. Okay, using such function, you can make sure the file which you have with you is the authenticated one. I hope this is clear, right? We'll move to the next topic here. See, I said there may be a collision, right? What does it mean? So that means, let me go to a particular slide. Huh. So consider this slide. Is it visible to everyone?
Yes, ma'am.
Yes. Ah.
Yes,
Okay.
ma'am.
Consider this slide where this is the input for the hash function, and when I perform the hash function on this input, it so happened that for two input, see for this name and this name, it what it generated the same hash value. Okay, so but according to the hash function definition, what it says, we should have a unique hash value for each and every input, isn't it? But here in this example you can say for two different input, I'm ending up with a single hash function or the same output for these two different input, right? So this we call it as a collision. Okay, so to analyze this problem, there is an example or a scenario considered in this chapter, that is birthday problem, or you can say birthday paradox. Okay, one second, I'll go to this particular topic. Huh. So to explain the collision problem, An example is given here, that is birthday problem. Okay, so let's see. uh, Let me explain what exactly the example is all about. Okay, so first consider there are n people in a room. So consider there are n people in a room, and you want to calculate how many of the people who are present in a room have the same birthday as yours. See, I'm consider I'm in a room. Okay, along with me there are n other people in the room. So I just want to find out who and all having the same birthday as mine. Okay, my birthday is on October 25th, so I just want to find out who and all having the same birthday as me. Okay, so that is the question here, and I just want to find out the probability of that. Okay, and it should be greater than or equal to 1 divided by 2. That means 50%. What are the 50% chances where the same person has the same birthday as mine in the same room? Okay, so this example is considered because it relates with the collision problem. Let's see how to solve this. Next, obviously my birthday will be on one particular day of the year, isn't it? And the other one, see, if a person doesn't have the same birthday as mine, then it falls on other day of out of 365 days, right? I mean, sorry, out of 364 days, isn't it? See, out of 365 days, one day will be my birthday, then other person will may have the birthday on other 364 days, right? So let look at this diagram. Or okay, for the same, the probability can be calculated by 364 divided by 365. I hope you are all clear with the probability, topic, like how it works, right? Yes.
Yes, ma'am.
Okay, let's consider this diagram. This is a birthday paradox. The example, whatever I explained here, listing out these points, I'll just explain considering this diagram. Consider this is a room. There are n people, and I'm here. Okay, I don't know how many people are there in this room, but my problem is that I just want to find out the person who shares the birthday date with me. Consider these two people have the same birthday dates, that is 19 November, and others have different birthday dates. Now, the question is, obviously, you can compare this problem with the collision problem with respect to hash function. Now, here you can see these two people have the same birthday date. I just want to find out then how many people should be there in a room, right? So that is the problem. That means what should be the input for the hash function to find out the collision? I mean, how many comparison I should make to get so that I can avoid the collision problem here. Okay, I hope this part is clear. Yes.
Yes, ma'am.
Is it clear? Is it clear to everyone, the
Yes,
birthday
ma'am.
problem?
Yes, ma'am.
Okay, next. So now uh, the question is the probability that all n people, so whatever the people, uh, those are present in the room, obviously don't have the birthday, same birthday as mine, right? So in this previous here, you can see all other people have birthday dates, their own birthday dates. It's not colliding with my birthday date, right? So that is what this statement says. So the probability of this can be calculated 364 divided by 365 whole power of n. Okay, so next is you have to find out the probability that at least one person has the same birthday as you. According to this diagram, I have to find out the probability of this, the one who is having the birthday with me. So that can be calculated by following this formula: 1 minus 364 divided by 365 whole power of n. Okay, since there are n people are present, you have to find out the n value here. So what I'll do, I'll equalize this equation with 1 divided by 2. So why it's 1 divided by 2? I just want to see here, I just want to find out the probability, like 50% of the chance, right? So that's why what I'll do, I'll equalize this equation with 1 divided by 2 so that you can find out the value for n. After solving this equation, you will end up with the value 253 for n. Okay, I hope this is clear. The first one is what? There are n people where I need to find out the probability someone has same birthday as me and it should be greater than or equal to 1 divided by 2. Obviously, you know that my birthday will fall on one particular day of the year. Okay, that is nothing but 365 divided by 365 probability of that. And then if a person doesn't share his birthday with me, then obviously his birthday will fall on other 364 days. Okay, and probability of that you can calculate by following this 364 divided by 365. Now you have to find out the probability of n people where they don't share their birthday with me. So that can be calculated by following 364 divided by 365 whole power of n. Fine. So now you can find out the one who is sharing the birthday with me. The birthday dates are same for both of us. So the probability of that chance or that point you can calculate by following this formula: 1 minus 364 divided by 365 whole power of n, and I'm equalizing this equation with 1 divided by 2. Okay, after solving this you can find out what is the value of n. So what is this n value here? This n value is the number of people that are present in the room. Okay, I hope this problem is solved. That means if you have 253 person in a room, you may find a collision. I mean, if you have 253 as the input for the hash function, then you may end up with a collision. Okay, so I hope this is clear. Yes.
Yes, ma'am.
Okay. Let's move to the next actual birthday problem. I'll just repeat these points. There are n people in the room, and the probability, I mean, how many people must be there in a room before probability is greater than or equal to 1 divided by 2. The same point I have listed in the previous slide. The same diagram is considered here, and this is important. Assuming that all birthdays are equally likely, the probability is given as 1 minus this 365 divided by 365 is 1. That is, my birthday will fall on a one particular day. That is this one. And this for multiply this with the person whose birthday will be on other 364 days. That is written here 364 divided by 365 till the last person. That is 365 minus n plus 1 divided by 365. And I'm equalizing this series to 1 divided by 2. Okay. After solving this, you will end up with n is equal to 23. Okay. This is the way how you find out the number of person in a room who with whom you can share the birthday date. Okay. So next, before going to this, I just want to show you the simulation. One second. One second. Huh. Just see the simulation here. One ನಿಮಿಷ. Is it visible?
No, ma'am.
One second. Stop sharing. Not able to. Is it visible? No, right? Are
No,
you able to
ma'am.
see any
No,
tab here?
not yet, ma'am.
Okay, one. Is it visible now?
Yes, ma'am.
Yes, ma'am.
Okay. So this is a birthday paradox experiment actually. They have just prepared this. Let's see how it works. Okay. So here the person, this is Razzle and this is me wherein I have entered my date of birth. I mean October 25. Okay. Now the question is, this person birthday is on November 5th and 15th. My birthday is on October 25th. And as you can compare here, we don't share the same birthday, right? But the problem is, I have to find out how many people do you think you need in a room to have a 50% chance that two people have the same birthday? Like whatever I discussed in the previous slide, okay? So I randomly given, I mean, I didn't calculate anything. I just enter it as 36. Okay, so let's see whether it is correct or not. So see, they say this seems like a good guess and sounds because there are 365.24422 days in the year, which is a lot. But if I say there are 36 people, then there will be 83.2% of chance of shared birthday. So let's see what. But I want 50%, right? So if I see, as you can see here, I selected as 36 people. That leads to 83.2%. So I just want to find out what is the 50%. So what is the right answer? It is the 23 people in the room. Let's see how it works. Okay. So they have given directly 23 people. Let's see how have they simulated it. You can see here. Let's enter 21 real people. Is it visible to everyone? Screen.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
You can see here the other 21 people are entering the room. I mean, birthday party. You can see here their birthday dates all are different. Okay. So here uh, it's the same one. The birthday date it is shared here. Okay. So let's run few more trials here. Okay, here for 23, I was the one and the Russell was another person. And 20, say 1, 2, and all other persons are the other one entered later, 21, and who are all having different birth dates, but wherein the one person is colliding with my birthday date here. Okay, let's run more trials on this. See here, 19 more groups of 23 people were entering the birthday party. See, it is just the trial, okay? So do remember 19 more groups are entering the birthday party. You can see the raising of this graph here, line. See, four success. I mean, you can, there 5 people are having same birthday as mine. Are you able to follow this? Yes?
Yes, ma'am.
ಹಾ ಇಲ್ಲಿ 7 ನೋಡಿ 8 success ಇದೆ. This is for 19 more groups. Okay. See here, you can see this is concluded that there are 50.7% of success rate. Now they have took few more trials where the sample size to run is 1000 trials ಮಾಡಿದ್ದಾರೆ with 23,000 people to visit. So you can see the success rate is higher, nearly 50%. I mean 1000 trials ಅಂದ್ರೆ ಎಷ್ಟು success rate ಇದೆ ಇಲ್ಲಿ 588, right? So half of it. That means if there are 23 people in a room, then the 50% chances the same person can have the same birthday with the other person. Okay, is this clear to everyone, the simulation? Yes.
Excuse me, ma'am.
Yes.
Does that mean that without disclosing their dates?
One second ma, your voice is not audible to me properly. One ನಿಮಿಷ ಕೇಳಿಸ್ ದೀಕ್ಷಾ ಒಂದು ನಿಮಿಷ ನಾ ಹೆಡ್ಫೋನ್
Okay.
ಬೇರೆ ತಗೊಳ್ತೀನಿ. ಸ್ಟೇ ಬಿ ಆನ್ ದ ಲೈನ್.
Yes, ma'am.
No, ma'am.
Ma'am, you're not audible.
Can you hear us, ma'am?